So yeah, first of all, thank you for joining us for this session. My name is Daniel. He is my colleague Mert. And we're going to talk today about the history of Android UI development, witness how it was evolved over the years, and try to predict what would come next. So in this session, we won't be bothering you with complex logic or algorithms, but rather present an overview about Android development and talk about its future. Here's our agenda for today. So first, I will start with a short introduction. Then we will travel back in time to the very beginning of Android development, see how the very first UI were created, and then we move to the XML era. Explore the Android UI annotations, Butterfly by Jack Wharton, data binding, Kotlin synthetics, view binding, and reach the top with fairly new Jetpack Compose. We will quickly share our experience, how we migrated to Compose, and finally, we will talk about the future of Android UI development and its potential evolution. So let's start with a short introduction. So Mert and myself are working at justeattakeaway.com, or simply Jet. It's a leading global online food delivery marketplace operating in 20 countries. So more specifically, we are working in the logistics department and developing apps for our couriers. So you have probably seen them on the streets and delivering food and groceries and big orange backpacks. So before we continue, I would like to start with a little question. So for how many years have you been developing Android? Like, just raise your hands. More than 3 years? OK, so almost everyone, I guess. Yeah. Then more than 5 years? All right, a bit less people, but still almost the same amount. And 8 years, more than 8 years? All right, a bit less. And 10 years? Oh, wow, cool. Nice. So then let's move on. So first, let's talk about the UI layouts defined in the activities. In the very early days of Android development, back in time to 2008 and Android version 1.0, UI layouts were created programmatically, directly in the activity classes using Java code at that time. So here you can see an example, how did it look like. So first, we create a linear layout, the simple views like text view, the button, all programmatically, right? Add them to the linear layout, then we just set the content view, and that's it. Looks neat, right? Well, maybe for the basic layouts it was working. But now let's take a look at this. So here's another Java code snippet with a bit more complex UI. So as you can see, it's a lot of UI code and it's very readable on the slide. It was actually intentional. So the UI adjustments like margins, colors, styles are done programmatically. So obviously a lot of code and activity classes, and also what about readability, right? So this approach was very tedious and error-prone, especially for complex UI designs. As Android became more popular and the app development became more sophisticated, there was a need for a more user-friendly and efficient approach to build UI designs. So next came XML era. So around the same time, when the first Android was released, XML was gaining popularity as a markup language for structured data. So XML is flexible, human-readable, widely supported, which made it a good candidate for describing UI layouts. So the Android team recognized this and decided to adopt XML as a primary language for describing UI layouts in the project. So here's a basic XML layout example. I won't be going into details this one, but you can see the structure, how it looks like. I guess everyone here is familiar with XML. We just presented less example here. So by using XML, it was possible to create complex UI layouts with less code, and of course, it was already more readable. Additionally, XML provided a separation between the UI logic and the application logic, so making it easier to maintain and update UI designs independently from the underlying code. So at first, the XML layout editor wasn't fancy as you see in these days in Android Studio. So developers were writing XML UI code without seeing any live preview. But luckily, with Android Gingerbread release, the palette tool was added to the Eclipse ADT. So at that time, Eclipse was like Android Studio those days. It gave the developers a possibility to simply drag and drop UI components, and of course, to see the live preview of your UI layouts and designs. It was a really big initiative at the time, especially for beginners. It was useful to start with Android development and quickly create UI layouts. Now, let's see if there were any problems with the XML and the UI code and activities in general. So obviously, long and complex UI code and in the XML and in the activities were the same thing. Also, there was a boilerplate code in the view classes coming from findViewById method. So actually, for more than a decade, Android developers have struggled with a simple but very annoying issue, getting the view reference from the XML to the view classes. So this code snippet shows how to get the view reference from the XML. So you have to declare separate variables for all the views you need from the XML layout, get the reference with findViewById. As you can see here, there's a lot of boilerplate code in onCreate, and only just to get in the references from the XML. So to prevent this issue, they were introduced new solutions to simplify the development and create more readable code. Now, let's take a closer look at the most popular solutions. Actually, many different libraries try to simplify the findViewById usage with different methods. But we will focus today only on those, because they're most popular. First, let's start with Android view annotations. The Android annotations library was introduced in 2011, and it provides UI annotations to simplify the development and to reduce the boilerplate code. So here is an example. So we just need to annotate the views with their IDs defined in XML, and they're ready for use. So quite simple. So as you can see, we annotate the text view, a button, an on-click function. Quite simple, as I said, and straightforward. So the Android annotation library gained popularity among Android developers due to its ability to streamline the development and to improve code readability. However, it has not been maintained since 2017 and is no longer recommended for use. So let's see now how many of you have been using Butterknife library. I guess almost everyone, right? OK, that's what I'm expecting to see. So the Butterknife library, created by Jack Wharton, has become super popular in Android community and has been widely used in many Android apps around the world. Right? It was sort of a standard way to avoid findViewById usage. Introduced was it in 2013, and then 6 years later, which is quite a long period of time, it was deprecated. Let's take a look now at this code snippet. So it uses annotations the same way as the previously presented Android annotations library. And under the hood, it generates the boilerplate code for us and reduces the amount of code that we had to write to get the reference to the views. So as you can see in this code snippet, right, we annotate a text view, a button, then string cursors, also on click function, the same way almost as Android annotations library with their IDs defined in XML, and they're ready for use, so like no boilerplate required. Also quite straightforward. Next big thing was the data binding library. So the data binding library was introduced at Google I/O in 2015, and it provides a declarative way to bind the data to the views using XML layouts and the data objects. So with data binding, developers can create more modular, testable, and maintainable code. So as you can see in this diagram, a view can observe the live data that is provided directly by the view model. And of course, it will represent directly the things that we bind from the XML to the views. So the data binding is much superior in terms of functionality. So it not only gives you the type safe and null safe view references, but also allows you to map your data with the views directly inside the XML layouts. Let's take a look at this code snippet or example of data binding usage. See on the right side, you can see the XML part, and on the left side, the code snippets from the main activity and the view model. So in XML, you have to declare, to encapsulate the content in the layout tag to support the data binding. The reference to the view model is defined in data tag, also here in XML on the right side. Then the mutable data, here in our example, is a greeting text defined in the view model, is referenced and updated dynamically in the XML layout. So you can see here the reference in the text view. Additionally, Android Studio will generate an activity main binding class that is used in the main activity to access the views if needed. So you have additional possibility to, let's say, to interfere and manipulate the data in the activities classes. So the best advantage of using data binding was or is that it allows to map the data directly with the views inside of the XML, as you can see in this example. You can also use two-way data binding to update your XML or data value without any listeners or callbacks. Yeah, data binding is still widely used in many Android apps today, and it's considered to be a very powerful tool for empowering development experience in Android. Next is Kotlin synthetics. So one of the biggest features Kotlin introduced at the time was the Kotlin extension methods, which included Kotlin synthetics. So Kotlin synthetics provide direct access to the views from the XML layout through the auto-generated Kotlin extension methods. So it allows to access the UI elements directly in the Kotlin code. Introduced was it in 2016, and then 3 years later, it was already deprecated. Actually, how many of you have migrated from Kotlin synthetics to, let's say, view binding or data binding? Do you have? OK, yeah, some people, right? So here's an example of Kotlin synthetics usage. So we simply need to import the generated view classes or view references from XML and use them directly in the view classes, as you can see here in the main activity. So we import Kotlin x.android.synthetics main activity XML reference, and then the button in this example and the clear button are directly accessible through the IDs. So we can set on-click listener and so on. So overall, Kotlin synthetics was a good option, but there were some problems which a lot of developers have faced while using Kotlin synthetics. So for example, if you set your content view to a layout, then type a view ID that only exists in a different layout, not in that one that you imported. So IDE, like Android Studio, lets you autocomplete and import that ID for you, right? So unless you specifically check that ID exists in your correct layout, basically that bind to the view, there is no safe way to verify that this caused a runtime issue. So it was quite dangerous if you don't do this verification manually. Then came transition to Android view binding. The Android view binding was introduced with the release of Android Studio 3.6 in early 2020. It is the feature of Android Jetpack library that allows to bind the views directly in the code with the generated binding class. So it provides also type-safe view references from the XML layout. Let's take a look at this code sample now. So you can see here an activity main binding generated class, which gives access to all the views in the layout. So it is initialized here on the create method to a binding variable. Then you can simply reference views by their IDs, like in this example, binding.button, binding.clear button, and so on. So it doesn't require actually any extra attention to layout files. It simply works on all layouts by default, which is very convenient. So the difference with data binding is that the view binding is used for the view references only. So it doesn't do any data mapping or two-way data binding. Here's an overview and the comparison of presented solutions, so based on our knowledge. The comparison criteria are nav safety, correct type of view, required boilerplate code, and build time impact. So as you can see, the clear winner is the view binding. In this comparison, it was one of the best options to use at that time. However, the data binding was another very good option, as it provides more functionality. It's already presented. So it was XML era and the journey so far. Now I'm actually wondering, how many of you have experienced all of those, or the most of the solutions we presented today? OK, yeah. Well, a lot of people, but I guess you don't miss the times, right, when you had to migrate from one tool to another one. So this is good. All right. And finally, announced and introduced in 2019. I guess you know what it is. At this point, I pass the mic to my colleague, Mert. Thank you for your attention.
Thank you, Daniel. Can you hear me? Yeah, nice. Yeah. As we said, you already know what it is. It's the Jetpack Compose era. It's the declarative UI app development toolkit that Android released in 2019, which has significant traction since its introduction in Google I/O at 2019. And it continues to evolve the fundamental part of the Android these days as well. But in this presentation, we will not deep dive into what Jetpack Compose is. Probably you heard that a lot, right? That already. Instead, our focus will be on the reasons what prompted Android to abandon this decade-old VUI system into this new declarative UI approach. I mean, have you ever thought that, like, why all of a sudden we decided to abandon that one and let's migrate to Jetpack Compose? Or was it all of a sudden? So we will try to endeavor gain insight on this topic and try to understand how long this technology or framework expected to be relevant, and could it sustain its momentum with the evolving needs of Android? In order to understand that, we need to take a look at these two key concepts, imperative UI programming and the declarative UI programming. So in imperative UI programming, developers write code that explicitly define the step-by-step instructions for creating and updating the UI. Imperative code often involves statements like create this view, update this element, set this property, and it focuses on the how aspect of the UI construction, where developers go and directly manipulate the code. And they just specify to make the changes by writing Kotlin or Java code. And if we give an example to this imperative VUI approach, is basically the traditional VUI system, that I said people were just writing by XML, Java, or Kotlin. On the other hand, you see on the right side is the declarative UI programming takes a different approach. Instead of specifying the exact steps for updating the UI, developers describe the desired outcome or the state without explicitly defining the implementation details. And they focus on the what aspect of the UI construction. The framework or library that you use interprets this high-level description and automatically handles the creating or updating UI part. These declarative UI frameworks that you use typically provide a set of components, properties, and rules for describing the UI. And examples of the declarative UI frameworks, as we know, as we're talking, Jetpack Compose and React Native, we can give it as an example. With that being said, you could easily tell the difference, I guess, which one is more compliant with the modern and evolving Android technologies. So on the left side, you see the imperative code. Even if you don't see the method details implementation, you could easily tell that from the signature what those methods do, like update order details, build order item card. And on the right side, you see the declarative. Even if we see all the code right now, we cannot even tell like what does this method do. It just like takes a UI state. We don't know what's that UI state. It just takes the UI state and reflects on it. Again, when we think about what channeled Android to slowly abandon this decade-old VUI system, first, in general, the whole mobile development world was going through the reactive implementation with the MVVM, and imperative view libraries was not cooperating very well with that one. And they tried with data binding. It was the first step to have the capability to react changes on that one with the live data, but it has its own limitations. It uses annotation processing, code creation, takes a bit more time, etc. And plus, you still need to go and write the XML code. Second, and possibly another reason, workarounds on the VVI system and the pile of tech debts that they have was one of the reasons as well. By the way, funny that both of the code blocks are from the same project, as we're slowly also abandoning the imperative VVI approach. I would like to give you a bit more detail in a nutshell how we're doing this. Our approach is we decided to decouple the view model from the XML layouts, getting rid of the data binding dependency module by module, detect the reusable components, write composables for that reusable components, already start using that ready composables in XMLs, and repeat and apply basically this one all over the modules. So you might be thinking right now that why do you even bother to decouple the view models from XML layouts? Just remove the data binding and write everything from scratch with Jetpack Compose. Well, the reason is that UI migrations not always get the first priority from the product team. And if you have a limited developer capacity, you need to do this step by step. So like, this is our own approach. You need to think about your own approach according to the use case. Luckily for us, that like Jetpack Compose and XML is like cooperating together very well. So we have the opportunity to put these Compose views into the XML layouts. And putting the Compose very right side of the chart here for the comparison, we can already see that like it's one of the winners. Like from the green check marks, you could say that like, oh, that's the same with the view binding, but we already talked about their difference, like imperative and declarative. So I think until this point, we can all agree that Jetpack Compose has undoubtedly made a significant impact in the Android development. While Jetpack Compose has shown great promise and widespread adoption right now, we can still say that it's in its early stages. And as developers, we must ask ourselves that, can it sustain the momentum? How we can make sure that like Jetpack Compose is here to stay? And can it adapt to evolving needs of Android system ecosystem? So, is it the future? When you try to do a quick research actually about the Jetpack Compose's future, the community is pretty excited right now. I did it, and like I saw these results are coming up. Will Jetpack Compose take over the XML? Jetpack Compose, the future of multi-platform development? And for example, there's a Reddit subthread here. They're asking that, is Jetpack Compose the future? People say, yes, 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 it is. There's Jake Wharton like in the middle saying, no, it's the present. Maybe he thinks that like Google will shut it down in 1 year, 2 years, I don't know. And also, what do we mean by the future of the Android UI? And how can we make sure that actually Google will not shut it down in 1 year? So in the second half of the presentation, we will basically brainstorm with you and try to understand this together and see what's lying in front of us. Well, according to the official website, this is their tech roadmap. And it says that performance is the first thing on their list, more support for advanced use cases, expanded material tree component set, improved tools including preview and live edit, this is for developers, platform support, Compose, very large screens, TV, etc. But this is only include the next few couple of releases in their plan. Therefore, it doesn't tell us their like 3 to 5 year vision about the Jetpack Compose. So in order to understand that, we need to think a little bit out of the box and even be more creative, speculative, what do you call it, in order to understand like which useful areas is for this Compose UI system. So what I did was basically inspiring from their current roadmap and adding my assumptions, my creativity, also seeing where it goes, in order to at least predict like what could be waiting for us in the future of Jetpack Compose. So you'll hear me saying a lot of mights and maybes in the couple of next slides. Taking a look at our first stop as well, it's the performance issues again. I believe performance is the most important factor, like at least one of the most important when it comes to decide on something or convincing your team to migrate to a new technology. And this should be our first visit. And there is a reason also why it's the first thing in Google's tech roadmap as well. So in the beginning of the Jetpack Compose, or even they released the stable version of it, a lot of people were reporting performance issues. And what was that? So first of all, it was a known issue that Jetpack Compose is slower than release builds on the debug builds. And they're working on to improve it. But it's actually a general fact that debug builds are slower in general, so regardless that you add the Jetpack Compose or not. And also, if we look closer, there are some extra steps and like extra configurations that you can do in order to bump the performance of the Jetpack Compose. What are they? According to the documentation, like the official Google website, you need to properly configure your app, and you need to minimize the unnecessary recompositions. What does that mean, unnecessary recompositions? Not going into that rabbit hole, but it's about the life cycle of the Compose. What we can say that in a nutshell, that Compose is smart enough to only update the affected part of the UI. And by using the state management techniques and structuring your code wisely, you can reduce the number of those recompositions, therefore resulted in improved performance. And the other thing is that they're suggesting you need to build in release mode and enable the R8 on those release builds. Plus, they also suggest you to use the build profile, baseline profile, which is already proved that's increasing the performance till 30%. As a take on this performance section, at least in my opinion, given how young Compose it is, it could be argued that it performed quite well comparison to the decade-old VUI system. So if you think about the extensive history of optimizations that they do on the Vue system and like how young Compose it is, I think this list of features that they're working on the performance can greatly improve them. Last but not least on this point, I would definitely recommend you to check this video. It's a conference talk from Christina Lee from this year's Kotlin Conf. She just like breaks down the Pinterest try and failures about the Jetpack Compose migration. Little spoiler alert, they decided not to do it because of the performance issues. But it's important to remember that that was a very early adaptation to try out for the Jetpack Compose. Our second step would be the customization and theming. So I think that we already know the customization and theming capabilities are essential for a brand and unique app experience. And as you see in the screen, Jetpack Compose has already introduced theming features, but there is actually a potential for further expansion, we expect. What they can be, in the future, we can anticipate more options for customizing and extending the default material components. And this can include the ability to create and apply custom themes, define reusable style sets, switch between the visual styles. You can think about from a real-life scenario. Your company wants to change the design system, but they also would like to give customers to switch between the old design system and the new one. If they're compatible with Jetpack Compose, you could give them that chance. You might be able to do that. Next one related to this one as well. Animation and motion capabilities of the Jetpack Compose. There's also a known fact that we are more attracted to using the apps when they use the animation and motion play. And while Jetpack Compose already supports some like basic animations, there's a scope for more advanced, powerful animation capabilities. So feature developments may bring those powerful animation APIs and easing the creation of complex and interactive motion effects. So this could include the support for physics-based animations, gesture-based interactions, and timeline-based animations as well. And I don't know, maybe even you can develop games by using the Jetpack Compose's animation API, if they are so powerful. And also you'll see on the GIF on the screen is that one of the famous animation libraries for Android called Lottie has already released their support around the Jetpack Compose as well. Next coming up, the cross-platform support. This is my favorite. While, as we know, it's initially focused on Android, there is a growing interest for leveraging Jetpack for other platforms such as iOS web and desktop. And starting what's already in hand, the Compose multi-platform, which is under development by JetBrains and the open source community. Remember with that Kotlin multi-platform, we were already able to write the business logic in Kotlin, but you will still need to go and write the native UI in Swift UI, CSS, or desktop UI, the UI code on the exact platform. But what they promised right now already, which is actually pretty cool in my opinion, accelerated UI development, as you will develop the same UI only once. Android skills for other platform. Lucky for you, if you know how to develop Jetpack Compose on Android, you can use those skills on other platforms without anything else. And an excellent ecosystem. Why? Because you'll be getting the support like one of the best ideas out there by JetBrains, plus the Kotlin community support, which is huge. As a take on this one as well, we can keep an eye on the future updates and announcements from Google. So probably they will also start supporting this one, and open source community regarding the cross-platform support for Jetpack Compose. Yeah, this is the screenshot from their GitHub page already. We can see that iOS is in alpha stage, Android is via Jetpack Compose, we know. Desktop supports right now Windows, macOS, and Linux, and web is experimental. And they already have this showcase application for the simple gallery, which they developed with the Compose multi-platform. Some of them are experimental, but again, like this already shows us the clear vision of the, like how Jetpack Compose is strong for the multi-platform support, right? We can already understand that. What else can we? So this will be the part, the last part that we're going to highly creative, and the speculation part is in there, like to be honest. That's why you're seeing the title as what else can be. The embedded system support can be. Why not? Because the lightweight and efficient nature of the Jetpack Compose makes it a potential candidate for embedded systems as well. So this can include IoT devices, smart appliances, automotive interfaces, digital signage, etc. And wherever the good UI design and initiative design is needed for any kind of embedded platforms. Second one can be the design and prototyping systems. So Compose's flexibility and ease of customization can make it a valuable tool for designers and prototypers. Design tools and prototyping software can integrate Jetpack Compose and provide a more accurate representation and more realistic experience for their customers if they would like to use it, and allowing them to interactive prototypes. Our closing thoughts on this future topic, so like what is waiting for us? As we talk on the recent 10 minutes probably, it has potential beyond Android, as we said, with the cross-platform capabilities, and possibly being embraced by the other domains and technologies. Looking ahead, it holds opportunities and challenges at the same time. As the framework continues to mature, we should expect further enhancements, improving performance, and expanded capabilities. So Google's commitment to investing in Jetpack Compose shows that, in my opinion, roadmap indicates a strong belief in its potential. So in conclusion, consider these opportunities and challenges, please. And don't forget, these migrations are highly situational and depending on your team's capacity and the product use cases. Thank you for listening us today. And you can catch us for the questions and answer after the presentation. Don't hesitate to reach us. We have this huge orange booth in front of the cube. So you can come there, win some free food vouchers. Yeah, don't be a stranger. Thank you.